Fine. So today's lecture is about mutation process, right? This is in continuation with the last lecture that we did about the crossover operator. Now see, when we talk about this mutation operator, I just want to give you a, follow up regarding what we have done earlier. We are doing and we are learning the genetic algorithm, that is the short form for GA. So in actually, what is the algorithm and what is the flowchart about the genetic algorithm we are doing? Let's move to this point to make you remember what we are doing. This is the first operator that is called as the selection operator, right? We have done this selection operator. Next operator, after working out with the selection of parents, what we need to do is we need to do the crossover. So that particular is called as the, when we apply the crossover operator, that process is being done. So this is the crossover operator, second point what we did. And now after this selection and crossover, what we are going to do is we are going to do the mutation over the children. See, firstly, what we did, we selected the best parents. We selected the individuals who can be the parents. And who can be the parents? The particular individuals which have a good fitness function will be the ones who are selected as parents with the help of certain techniques which we did in the earlier lectures. Then what we need to do is, when we are doing the selection, after that reproduction takes place. So when we are doing the reproduction, we need to do the crossover. Why we need to do the crossover? We need to do the crossover just because if we are not using this crossover operator on that particular individuals, on those particular child, then what we are going to get? We are going to get the same parent as the same child. That means the child will be exactly the same as the parents. So what we did, we swapped certain bits of child 1 with parent 2 and with parent 1 to child 2. So this is how what we did. We swapped certain bits and we said that certain properties of child 1 are inherited from parent 1 and certain properties are inherited from parent 2. So that makes the recombination. So that is why crossover is also called as the recombination operator. Now we are coming to the part that is called as the mutation, what the lecture is all about. So basically, what is mutation process? It is the process by which a string is deliberately changed so as to maintain the diversity in the population set. Now what we are basically doing here is we are going to flip the bit. We are going to change the bit of a particular individual chromosome. Why we are doing that? We are doing this to maintain the diversity in the population. That means to make the new individuals diverse, we are using this particular mutation process. In this, we have flip bit. What is this flip bit? This is the mutation operator. Mutation operator simply inverts the value of the chosen gene from 0 to 1 or 1 to 0. Let's take an example. Let's say we have an individual chromosome which has the bits, this one, right? So what we are doing, this is a chromosome, this is a individual population, and if we are applying the mutation operator flip bit here, so what we are going to do, I will randomly choose any bit. Let me say that I have chosen this particular bit, right? And I am going to flip this bit. If it is 0, I'll make it 1. And if it was to be 1, I'll make it 0. So the new chromosome or the new individual I get is by flipping the bit from 0, I'll invert it this bit to 1. Others will remain the same. So here you can see 1 same, 0 I have flipped this bit as 1, 1 same, 0 same and 1 same. Right? So randomly I'm going to select a bit and I'm going to invert or flip that bit. What is inversion? Inversion operator inverts the bit between two random sides. That means this is the one which I have selected just a single bit. And if I say I select a random side, let it be this side. So I would do what? I will invert these two bits. Now it would have been 1, 0, 1, 1 and 0. Why this? So I have copied these bits same 1, 0, 1. Okay. And I have flipped these two bits. For 0, I have made it 1 and for 1, I have made it 0. So this is how the inversion of flip bit is taking place, right? So this is how the mutation process takes place. Now this is just an example I have given. Let's say this is a individual chromosome on which I am applying the mutation operator. So this is flip bit 1, 1, 1, 1, 4 times 1. So what I'm going to do, let's say I have selected this particular bit. What I'll do, the other bits will remain same and only this particular bit will be flipped to 0. So it will be 1 same, 1 will be converted to 0 and 1 and 1. Okay, so this is 1, 0, 1, 1. So this is how the mutation operator takes place. Operation takes place. One more example, let's say this is the 1, 0, 1, 0, 0. So I've selected this particular bit to invert. So this will be 0, 1. I'll make it 1, 0. So 0, 1, 1, 0. Okay. So this is the mutation. Now, what is mutation rate? Mutation rate is the probability of mutation, which is used to calculate the number of bits to be muted. Here I have seen that we are just mutating only single bit, right? Now, in different cases, we are going to mutate different number of bits. So how we select or how we calculate the number of bits which are to be muted, that is called as the mutation rate. So the probability of mutation, which is used to calculate the number of bits to be muted, is called as the mutation rate. Now mutation, we have different types of operators. First one is called as the bitwise operator. Right? What is this bitwise operator? Bitwise operator means what I'm going to do, this is called as the unary operator. Unary operator means only single operand is present, right? So it is an unary operator that causes the bits of operands to be inverted. Here what I'm going to do, let's say this is a chromosome. This string of chromosome is there, 0, 1, 0, 0, 0, 0, 0, 1. And what I'm going to do when I'm applying the bitwise operator, I will invert all the bits. From 0, I'll make it 1. From 1 to 0, 0 to 1, 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 and from 1 to 0. So what I have done, I have done nothing. I have just inverted or flipped all the bits. That is how I apply the bitwise operator. Now this particular bitwise operator is divided or branched into three types of bitwise operator. First one is called as the bitwise AND operator. Second one, bitwise XOR operator, and third one as bitwise OR operator. So you can just see these particular operations you have already performed. You know what is AND, how the truth table takes place of AND, for XOR and for OR. So this is what we are doing in the same condition. First one, if we have bitwise AND operation and we have two parents, right? So this is parent 1, this is parent 1, and this is parent 2. Now I'm going to create the child which has bitwise AND operator applied to it. So what will be the child? It will be when I'm applying the AND operator to this. So just apply this AND operator here. 1, 1, I'll get 1, 0, 1, I'll get 0. Why this? Because in the AND table, if you remember, if I have 0, 0, I'll get 0. If I have 0, 1, I'll get 0. If I have 1, 0, I'll get 0. And if both are 1, only then I'm going to get the 1. So this is what? This is the AND operation, right? So here 1, 1, I'll get 1. For 0, 1, I'll get 0. 1, 0, I'll get 0. 0, 0, I'll get 0. 1, 0, 0, 0, 0, 0. 1, 1, I'll get 1. and 0 1, I'll get again 0. So this is what I'll get the answer about this AND operator, right? Now similarly we are going to apply the bitwise XOR operator. So let's understand the XOR table. I know that you all are aware of this particular table. When we do the XOR, what we do, if we have 0 0, what we get? We get 0. If we have 0 1, we get 1. If we have 1 0, we get 1. And if we have 1 1, we again get 0. So this is our the XOR table is. That means whenever we have single bit as 1, we call it as the output 1. So parent 1 and parent 2, based on this particular table, we are going to apply this. This is parent 1, this is parent 2. 1 1, the child will get 0. 0 1, 1. Again 1 0, 1, 0 0 0, 1 0 1, 0 0 0, 1 1, 0 and 0 1 1. So this is the child we will get applying the bitwise XOR operator. Now we have bitwise OR operator. Now here we are going to apply the OR table. So for 0 0, what we used to get? We used to get 0. For 0 1, we used to get 1. For 1 0, we used to get again 1. And for 1 1 also, we used to get 1. So this table is again applied to this. This is parent 1 and this is parent 2. So when we apply the child on, when we apply the bitwise OR operator for the child, we get 1 1, I get 1, 0 1, 1, 1 0, 1, 0 0, 0, 1 0, 1, 0 0, 0, 1 1, 1 and 0 1, again we get 1. So finally we get the child as this particular string. Okay, so these are the three logical bitwise operators, that is AND, XOR and OR. Now we have the shift operators. This is again the another type of mutation operator. This is shift left operator and shift right operator. This is divided into two again. So left operator, when we say shift left operator, how do we shift left operator? Let's say this is a chromosome A, string of chromosomes, that is 1 0 1 0 0 1 1 0. So when we apply the shift operator, let's say we are applying the shift left shift with the 2 bits. Okay, so this is the symbol of left shift. This is the symbol of left shift. This means that we are applying the 2 left shift to the A chromosome, string of chromosome. So what we are going to do, we are going to shift here. We will leave 2 space empty, let's say, and we are going to shift these bits here. 0 is here, 1 is here, 1 comes here, 0 comes here, 0 comes here, and 1 comes here. Just forget about these 2 bits. Okay, and here where 2 spaces are left, we will put 0 by default. Okay, so this is what we give the left shift operator. Now, when we do the right shift, so the symbol says that if it is a string of chromosome out here as A, what will we get with the right shift to right shift? This is the symbol. So what we are going to do, again, now from this particular side, from right side, we are going to provide the shift. So I'll leave 2 spaces empty and I'm going to shift this 2 bits. So I get 1 here, 0 here, 1 here, 0 here, 0 here, and 1 here. Now you can just delete or forget about these 2 bits. And by default, you are going to put 0 in these 2 empty spaces. So this is how we are going to do the left shift and the right shift. Okay, so what is basically the mutation operator? In conclusion, we say mutation represents a change in the gene. Why we are providing the change in the gene? Because we are going to flip any of the bits which we got as the child. Next, mutation is a background operator. Its role is to provide a guarantee that the search algorithm is not trapped on a local optimum. So what does this mean? sometimes in genetic algorithm, the solution we get is the local optimum is met and it just loses the global optimum. It get trapped, the solution get trapped in the local optimum only. So to reach it to the global optimum, we need to provide the mutation operator. Okay. This guarantees a better solution. The mutation operator flips a randomly selected gene in a chromosome. This we all know. We have already seen in a chromosome, randomly we select a bit and we flip that particular bit with the help of this mutation operator. Now we have already seen what is mutation rate. So the mutation probability is kept very low in GA, and what the range is? The range is from 0.001 and 0.01. So this how small this is kept as very low in the genetic algorithm. But it is important to provide the mutation operator. So that's all for this particular mutation process lecture. Thank you very much.